Hey guys, welcome back. Chapter 11, Section 2, everything to do with now calculating volumes of prisms and cylinders. Alright, so this topic of volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. So when we come over to the right and we look at this example, well, we know that a cube built out of 27 unit cubes has a volume of 27 cubic units. What I want you to take away about volume and what we're going to be getting into is we want to know how much stuff a figure or a solid takes up, how much stuff is inside of it. Alright? So that's really what we're getting down to and what we're going to be doing in this section. Now this next box, Cavaliers Principle, it's a big name. I don't want you to worry too much about it. It's not super important that you, again, know what it is, but just that you know that it always works. Alright? So if two three-dimensional figures have the same height and have the same cross-sectional area at every level, well, then they have the same volume. This might be confusing when just reading, so I like to show you, or I'd want to show you this picture that shows you that both of these two figures or solids have the exact same base, right? Right here, same base, alright? So these solids have the same exact base, and if you notice, they end up having the same height as well. This height right here is an actual edge. Now in this one, you have to do a little bit of work. You might have to dot a line. But what do we notice? This length right here is the exact same as this length right here. They both have the same height. So regardless of whether we have a right prism, we call this a right prism because the sides or edges are perpendicular to the bases, or if we have an oblique prism where the height isn't necessarily an edge, well, you're going to have the same volume regardless. Okay? So if we write that down, we have a right prism and an oblique prism with the same base and same base and same height, sorry. Well, they have the same volume. That should seem familiar because we learned last chapter that a triangle something like this and a triangle more like this, when these bases were the same, it didn't matter whether the height was inside or if it was outside. As long as it was the same height and the same base, these had the same area. So we use the same concept with volume. Now we're ready for some formulas. These are what we're going to practice today, okay? These problems, solving for the volume of prisms and cylinders. So here we go. The volume of a prism with base, area, B, and height, H, is V equals capital B, H. Please make sure you understand that this is capital B. I do not want you to confuse that with lowercase b. Lowercase b is usually the base of a two-dimensional shape. Capital B is the base area of a three-dimensional shape. Okay, so very specifically, if we have a rectangular prism, you can always use V equals L times W times h. And really, that's why is that? Well, because if we were going to calculate the base area, right, if we needed the base area of this rectangular prism, well, we would do L times W. So that would be for big B, and then LW times the height of h just gets you LWH. Also along those lines is the volume of a cube. We can always say that the volume of a cube is s cubed. And again, why? The area of the base is going to be s times s, or s squared. And then we would have to multiply that base area times the height, which again is s. So s squared times s is s cubed. This is really what I want you to focus on, that the volume of a prism is always equal to the base area times the height. Now, the volume of a cylinder is actually the exact same thing. We just like to put in a slightly different formula so that it's a little bit easier to remember. All right? So the volume of a cylinder with base, area, B, radius, R, and height, H, is still volume equals capital B, so base area times height. But what do we know about the base area of a circle? Or sorry, the base area of a cylinder? Well, that base is a circle, and we know that the area formula for a circle is pi r squared. So really what we can do is we can always say that a cylinder will be pi r squared, because that's the area of a circle, which is the base, times height. All right, so now as we move on to the next page, I think there's a little bit more notes, but then we're going to get into some practice problems. Okay. So, we need to recall that the height h is always perpendicular to the base of a figure. When I'm talking about this, I'm talking 2D, or I'm talking about if I give you a parallelogram, I know that this is going to be my base, and I know that the height has to be what? Perpendicular. Okay, so that is what I'm kind of talking about when I'm talking about the height is always perpendicular to the base. The same thing happens when we move from two-dimensional shapes to three-dimensional solids. Okay, in a solid, the height is the perpendicular distance between the two bases. This is pretty important. This is something that I would really want you guys to understand as we move forward and practice these problems. So let's get to it. All right. If we look at number 1, it says that we want to name each solid, then find the volume, round to the nearest tenth. Well, if I want to name each solid, I'm going to need to find a base, right? I need to find a base because that allows me to name the prism. I know this is a prism because I can tell that these are my two bases. They are parallel and they are congruent. So those are rectangles, meaning this is a rectangular prism. And now we need to find the volume. We have a couple of options. We can use that formula from the page before. For rectangular prism, we know that it's V equals length times width times height. So, all we really have to do is figure out what each one of those values is. If I go to my picture, I could say that maybe the length is 11, the width is 6, and the height, the perpendicular distance between my two bases, well, that's right here, the 14. So all I would do is I would go to my calculator, plug it in. 11 times 6 times 14, V equals 924. 924. Be careful, we're no longer using square units, we're using cubic units, because we have 3 dimensions. So we should use meters cubed. If we move on to the next picture, number 2, we need to first identify what are the bases, I should say. All right, so let's see here. I would say, if I'm looking at this, that I have 2 identical, so congruent, and parallel triangles, meaning I have a triangular prism. Now, I need to figure out the area of the base, right? Because our general form of volume is area of the base times the height. We might have to do a little bit of extra work here. So what I'm going to do is I'm actually going to sketch an extra picture of the base. All right, I knew it was a right triangle because of this right angle. I also know that the hypotenuse is 5 and maybe this leg is 4. So what can I do? Pythagorean Theorem. 5 squared equals x squared plus 4 squared, or 25 equals x squared plus 16, or 9 equals x squared, or x equals 3. All right, now I know the dimensions of my base. So what I can do is I can say that capital B, because it is a triangle, is going to be 1/2 little b times h. Do you guys notice? This is why it's important to understand the difference between capital B and lowercase b. Lowercase b is the base of my triangle. Capital B is actually going to be the area of this triangle. So when I plug everything in, 1/2 times 3 times 4, well, I'm just going to do this in my head. 1/2 of 4, that's 2. 2 times 3 is 6. So the area of my base is 6. Now I can keep going. Volume equals 6, because my base area was 6. And then the height, or the distance between the two bases, is also 6. So that's a 6, meaning the volume of my triangular prism is 36 kilometers cubed. Not that bad. Not that bad. As we move on to the last problem, the last volume that we're going to calculate, hopefully we all recognize this has circular bases. There's also 2 bases, which means this is a cylinder. We remember from the page before that we have a specific volume formula for cylinders. We use pi r squared h. Well, that's really nice because I already know the radius, I already know the height, or the distance between the two bases. So V equals pi 4 squared times 12. Here I might go to the calculator. I can do pi times 4 squared times 12, and I'd get 192 pi. That I would probably leave as an exact value. If you don't want to, you can also answer as 603 point, and I believe the instructions, said 10th, so 603.2. Please remember that this will be in centimeters cubed. Both of these answers perfectly acceptable. Alright, so now we've worked forwards. By that I mean I give you dimensions and you find the volume. As we move on to page 7, we're actually going to start and try to do some where we work backwards. Alright, so let's take a look at number 4, where now I give you a volume and I give you a bunch of dimensions, but we're missing a height, okay? So V equals capital B H. What do we have to notice here? Well, we need to recognize what is our base shape. Our base shape is a trapezoid. Alright, we have two parallel congruent trapezoids. So what I'm actually going to do, guys, is I'm going to calculate the area of that trapezoid first. So I'm going to sketch it, maybe mark this. This I know is 5 from this, and I knew my bigger base was 9. It also told me that the height of the trapezoid itself was 4.6. So I have everything I need to calculate the area of this trapezoid. So here, capital B is going to be 1/2 times the height times the sum of the bases. Notice the lower cases. And when I plug everything in, 1/2 times 4.6 times 5 plus 9, go to the calculator, 0.5, 4.6, 5 plus 9, I get that my base area is 32.2. Okay, now that is important because now I have enough information to solve for the height of the prism. The volume equals capital B times H. Sorry, I just rewrote that. So now when I plug in 450.8, because that was the volume that they gave me, and I knew the base area was 32.2, and I'm solving for H. Alright, hopefully we all understand and see that this is a simple division. H will equal 450.8 divided by 32.2, and we get a height of 14 inches. We're getting there, almost done. Here we go. We have a cylinder. We know that the cylinder has a volume formula of pi r squared h. Let's plug in what we know. We know the volume is 180 pi. We do not know the radius. We do know the height, 5. So if I clean this up a little bit, this is going to look like 180 pi equals 5 pi r squared. So here's what I'm going to do, guys. I need to solve for r. Now, I know I'm asking for the diameter. You have to kind of make the connection that if you want the diameter, you can get that from finding the radius. So what I'm going to do is divide both sides by 5 pi. Alright, so the 5's cancel, the pi's cancel, the pi's cancel. 180 divided by 5, I'm not feeling good on my mental math right now. 36 equals r squared, and then we square root. So we get that r is 6. The last thing you have to do, again, make that connection. We know that the diameter is always just twice the radius. So 2 times 6 is 12 centimeters. Last problem, almost done. Thanks for sticking with me, I appreciate it. Here we go. Area of the base of a pentagonal prism with volume 84 meters cubed and height 7 meters. Okay, so we just want the area of the base. So that means we're just looking for capital B. So let's start with our formula. Volume equals area of base times height of the prism. Let's plug in what we know. 84 equals, we don't have the area of the base, so I leave it as a variable. I know the height is 7. So guys, notice, remember, this is multiplication. How do I reverse multiplication? Divide. When I do that division, I end up getting that the area of the base here is 12 meters. Alright, so that's a good start on solving for volumes of prisms, and then also working backwards to find dimensions from a prism or cylinder. Thank you guys for listening. I appreciate it. Please make sure to jot down any notes or ask any questions, send me emails, whatever you got to do.